We introduce 5 representative membrane builder models, each serving a distinct purpose. Double bilayers model fusion pathways, focusing on the rate and barrier from stalk to pore formation. Vesicles are used in LNP delivery, supporting encapsulation, stability, and release. Micelles represent detergent assemblies, characterized by critical micelle concentration and aggregation number. Hexagonal phase structures capture curvature stress and non-lamellar stability. Nanodiscs provide a native lipid patch, maintained by scaffold proteins for order and affinity. In this demo, we will introduce Micelle in detail. In the left sidebar, go to MolCube Builder and select Membrane Builder. First, type your project title, 2HAC. Next, under Membrane Type, select Micelle, since we'll examine how detergents surround the 2HAC protein. Then load 2HAC via PDB reader, the zeta-zeta transmembrane dimer of the T-cell receptor. Finally, click Submit. Step 2 is alignment. You can use as-is, principal axis, or ppm. Here, we'll use ppm to place the transmembrane dimer properly in the detergent micelle. After choosing the options, click Submit. Step 3 defines the detergent environment, where you can also set the micelle radius to control the overall size of the detergent assembly. For this demo, we'll use the default SB310 detergent, a commonly used zwitterionic surfactant for micelle formation. Then click Add to insert the detergent. Since the known aggregation number is 41, set the number of detergents 41. Finally, click Submit. Step 4 is the stage where you check the lipid packing through visualization. After reviewing it, click Submit. Step 5 configures your environment. Choose whether to neutralize only or add a specific ion concentration. Set your temperature, Kelvin. Optionally enable hydrogen mass repartitioning for a 4 femtosecond time step, and select your MD engine such as GROMAX. After reviewing the options, click Submit. Step 6 is the final review. Confirm the 3D visualization and system info look correct. Then download your PDB, GRO, TOP, XML, or the full project bundle for local runs or MolCube simulator.